So we continue with the next speaker, and that one is from JA Solar. So we're happy to have with us Jerry Sun, who's the Senior Product Promotion Manager at JA Solar. And Jerry will talk to us about factors affecting the reliability of high power modules and how to control them. Jerry, the floor is yours.
Okay, hello. I'm sorry. Wait a minute. I share the screen. Is the share working?
Perfect. Presentation
okay,
mode.
Okay. Hello, everyone. This is Jerry from JA Solar. Next, I will talk about JA Solar N-type module technical feature and the reliability analysis. Deep Blue 4 module technical feature. As we all know, as the P-type PERC cell reaches the peak efficiency of the mass production, N-type cell will be put into large-scale mass production. Next, let us look at the JA Solar high-efficiency N-type module, Deep Blue 4, 0.0x. The following introduction, we call it Deep Blue 4. This kind of module was released for the global market in May this year. Deep Blue 4 module adopts two core technologies, Vacuum Plus and GFI technology. So the module efficiency and power can be effectively improved. At the same time, Deep Blue 4 module also has 4 power generation advantages: lower degradation, lower temperature influence, higher beneficial benefits, and better low light performance. Next, I will introduce these features in detail. Vacuum Plus cell is based on low oxygen N-type wafer with mature 182 millimeter size and adopts optimized passivation and contact technologies. The VOC of the cell can reach 720 millivolts, and the efficiency can reach 25%. As we all know, module efficiency is improved both by better cell efficiency and high density module encapsulation. The Deep Blue 4 module adopts JA Solar's patented high density module encapsulation technology, gapless flexible interconnection, and what is the GFI technology? The round ribbon has a special buffer treatment that handles mechanical stress at cell interconnections and thus eliminates the risk of micro cracks. At the same time, JA Solar maintained the standardized size of the modules by adjusting the size of the silicon wafers. Which ensures versatility for downstream applications. Okay, GFI technology is compatible with current mainstream module encapsulation technology, so that module efficiency can be increased by about 0.4%, and the module power can be increased by about 10 watts. Compared with conventional modules, GFI modules can have a certain system cost advantage. The efficiency of Deep Blue 4 module can reach 22.4%, which is about 1% higher than the p-type module. And the 78 cell module power can reach 625 watts. This is about 25 watts higher than p-type modules. Due to the natural advantage of N-type wafer for the LID-free and the brighter LETID performance compared to conventional PERC cell, GA Solar offers a 30-year linear power output warranty with less than 1% degradation in the first year and less than 0.4% annual degradation in the following years. A one-year field test performed by GA Solar and TaiyangNews shows that the first year power degradation is about 0.15%, and this is considered by the industry to be excellent degradation performance. You can see here. As for the high temperature energy yield performance, mainly related to the temperature coefficient and module operating temperature, the Pmax temperature coefficient of Deep Blue 4 is minus 0.3% per degree Celsius, which is better than minus 0.35% per degree Celsius of conventional p-type modules. At the same time, due to the higher conversion efficiency of the N-type module, the heat conversion of the absorbed light energy is correspondingly reduced, thereby reducing the operating temperature of the module. GA Solar and TAiyangNews field test shows the average operating temperature of the N-type module is about 1 degree Celsius lower than that of the p-type module. Together, these bring about 2% power generation higher than that of the p-type PERC modules. Regarding beneficial generation performance, the N-type module has 80% beneficiality, which is much higher and brighter than the 70% of p-type PERC modules. The 10% beneficiality difference can result in power gain of 0.8% to 1.2% for the N-type module. Okay, for the last feature, as for the low irradiance energy yield performance due to Bition class cell, brighter internal resistance design, higher minority carrier lifetime, and open circuit voltage, the cell's low irradiance performance is superior. Under 600 watts per square meters conditions, like in the morning and all fall simulation, the simulation results shows the N-type energy yield gain to be about 0.2%. Okay, in addition to the module power efficiency, power generation performance, module reliability is also important to the module performance. Part 2, I will introduce the Deep Blue 4 reliability analysis. Regarding the module reliability, normally the reliability of modules is ensured by reliable solar cells. advanced module encapsulation process, excellent module encapsulation materials, optimize the module configurations, design, rigorous and comprehensive reliability test. Next, I will talk about each of these 5 aspects for the Deep Blue 4. First, as mentioned above, Basium Plus is based on low oxygen N-type wafer without boron and oxide complex. So it has LID-free and better LETID performance. Second, for the module encapsulation process, using the advanced encapsulation process, combining with information and automation management, at the same time adopting the effective and reliable GFI technology. Third, Deep Blue 4 module adopts the high performance materials such as encapsulation materials, POE or EPE, thinner ribbon for SMBB technology, and for the encapsulation film, JA Solar did a lot of research and test for the, especially for the EP film. The POE layer thickness should more than 150 micrometer. We ensure the PLA performance of Deep Blue 4 by controlling the thickness of POE layer. And thinner ribbon of SMBB needed to optimize module process to ensure the precision of the welding. Of course, new structure encapsulation material is also important. JA Solar has made a lot of tests and research. Fourth, Deep Blue 4 module with the mature 182 wafer size has a proper and reasonable dimension size. Unlike the large size modules, which has a certain mechanical load risk, transportation and installation, and risk and structure loading capacity. The larger, the better. I think improvements of module efficiency should be trend in the future. The last one for the high density module, the macro crack at the cell interconnections is the key indicator. From the EL picture, we can see the GFI module with special buffer treatment solves the macro crack risk well. You can see here, no macro crack. But the other high density module without special treatment at cell interconnections still have some macro cracks. You can see here. These macro cracks will be aggravated with subsequent module transportation and installation. We can use the mechanical load test to test the macro crack status after the mechanical pressure. From the EL pictures before and after the standard mechanical load test, we can see Deep Blue 4 module has no macro crack at the cell interconnections and has the excellent mechanical load performance after the standard mechanical load test. the test result shows DFI technology can effectively solve the macro cracks. Specifically, the IEC standards require a module power the module power loss less than 5% after the reliability test. From the left figure, we can see the power loss of the Deep Blue 4 is only around 2%, and this is which is far below the IEC standards. So this module has excellent reliability. Part 3. Next, part 3, I'd like to talk about the Deep Blue 4 customer value analysis. As we all know, LCOE is a core indicator to measure a PV project. Module-related factors include module price, module power, module efficiency, module energy yield performance, and long-term reliabilities. As we all know, within a certain module size range, higher efficiency and power can reduce the bill as cost effectively. In addition, as for the energy yield performance, GA Solar and TOV Node operated 1-year field test at the CPVT National PV experimental base in Yinchuan of China. The result shows the energy yield of the N-type module based on bi-polar cells is 3.9% higher than that of the P-type modules. The N-type modules' theoretical power generation gain is about 4%. Due to the lower degradation, superior high temperature, energy yield performance, higher bifacial generation gain, and excellent low irradiance energy yield performance. This number, I think this number is consistent with field test data and publicly available industry statistics. Okay, take a 100 megawatts project in Dubai as an example, taking into consideration the cost of rack, foundation, cable installation, and land area. Deep Blue 4 module can reduce the BOS cost by about 2.1% and LCOE by about 4.6%. Okay, at the same time, from the right chart, we can see the LCOE can be reduced by about 3.5% to 5%, depending on differences in regions, climate conditions, and the projects. Deep Blue 4 module mainly includes 3 dimensions design, 54 cell, 72 cell, 78 cell, different modules for different application scenarios. 54 module for residential PV systems, 72 cell and 78 cell module for CNI and utility scale PV plants. Finally, for the capacity of the Deep Blue 4 modules, by the end of 2022, the plant capacity can reach 27 gigawatts or more. GA Solar has the ability and confidence to provide PV modules.
Hi, Jerry. Hello. Okay, thanks for the presentation. Jerry, if you have still time, it would be great if you could answer some questions on the chat.